Hi everyone, thank you so much for your interest in our work. My name is Giulia Barbareschi, and today with my colleague Kathy Holloway, I'm going to be talking to you about our work on the social network, how people with visual impairment use their mobile phones in the Kenyan informal settlements of Kibera. This work was conducted by the UCL Interaction Centre and the Global Disability Innovation Hub in partnership with the University of Nairobi and the Kilimanjaro Blind Trust Africa. And it's part of a larger program of research funded by the UK Department for International Development called 80-20-30, Life-Changing Assistive Technology for All. As most of you probably know, mobile technologies can offer great support to people who are visually impaired, both as social enabler, but also as more traditional assistive technologies. There are over 5 billion mobile users worldwide, and this number are continuously growing, and the upward trend is mainly led by low and middle income countries where more basic phones are commonplace. For this reason, in recent years, several researchers in the fields of human-computer interaction and international development have started to look at how people with visual impairment who live in low and middle-income countries make use of their mobile phones to increase independence and participation in their daily life. Some researchers have developed new low-cost solutions that enable visually impaired people who are basic or feature phone users to have access to social media and navigation services. As expected, smartphones do offer significant advantages in everyday life compared to basic or feature phones, but the transition from a button to a touchscreen interface is often long and complex for many people with visual impairment. Finally, regardless of the availability of features and services, the barriers and characteristics of the mobile ecosystem determine how mobile phones are used by visually impaired users. For example, a smartphone can offer GPS-based navigation services. However, their usefulness can still be severely limited by failures of the network or usability issues. The social context in which people live is probably the most crucial aspect that shapes not only how people use mobile phones and other technologies, but also the broader experience of disability. To describe the complex web of people, environment, aspirations that shape how technology is used, researchers have formulated the concept of human infrastructure. These complex networks of people and environment can determine both why and how technology is used in different contexts. It is also important to remember that the human infrastructure of technology is often more prominent in low and middle income countries where technology use is shared by different actors. Human infrastructure gives rise to different ways to use technology, such as direct or mediated by intermediaries, that either interact with the technology on behalf of the user or support them by simplifying the interaction. Our study took place in an informal settlement. Informal settlements, otherwise known as slum community, represent a unique urban ecosystem with specific organizational, societal, and infrastructural characteristics. Most informal settlements developed as unplanned urban communities that are situated at the periphery of large cities in many low and middle income countries. Informal settlements are also characterized by high level of poverty and scarcity of services. However, thanks to their proximity to large urban developments, residents of informal settlements enjoy better access to opportunities compared to many people who live in rural communities. The trade-off is that these are also places of overcrowding and have poor road infrastructure, which means that most roads are narrow and unkept, leading to severe barriers to navigation for many people with disabilities. On the other hand, people living in informal settlements are more likely to be free from traditional social hierarchies and constraints that shape rural societies, enabling the creation of wider and more diverse social relationships. Finally, the increased resilience to change of most informal settlement residents creates more openness and willingness to engage with technology in creative ways. Building on these 3 strands of research, we formulated 2 research questions for our study. The first one is, how does the social environment of visually impaired people who live in the informal settlement of Kibera in Kenya shapes the way in which they interact with mobile technology? The second is, what kind of interactions would people with visual impairment who live in Kibera want to have in the future, compared to the interactions that they have available now? To answer our research question, we developed a two-stage research process to explore both current and future interactions between visually impaired people and mobile technology. Our first step was to conduct a series of contextual interviews, followed by ethnographical observations of 6 visually impaired Kibera residents. Our aim was to identify the types of interactions participants had when using their mobile phones for different purposes, and to understand how these interactions are characterized by their social components. To gain a comprehensive understanding, we also conducted a few additional interviews with key members of the human infrastructure of the participants, focusing on exploring their role as technology intermediaries. Data from interviews and observation was analyzed using thematic analysis, and the findings from this initial stage of research were used to develop 2 storytelling and modeling activities for a co-design workshop with an additional 10 visually impaired people living in informal settlements. The aim of the workshop was to engage participants in exploring the way in which they aspire to interact with technologies and their social environment in the future, and understand the role that they envision these interactions could have in achieving more fulfilling lives. I'll now leave you to my colleague Kathy, who will be walking you through the results of our studies.
Thank you, Giulia. I will now take us through the results. From the first study, we identified 4 types of interactions that the participants had when using their mobile phone. These were direct interactions, supported interactions, dependent interactions, and restricted interactions. Direct interactions, as you can see here, were categorized by independent mobile use by the VIP. Although these direct interactions were mainly described in relation to mobile phones, they went beyond the use of mobile phones as people spoke more generally about interacting with basic appliances, for example, kettles and radios. Direct interactions with mobile phones were facilitated by physical buttons on feature phones and basic phones, and on smartphone, these were facilitated through a screen reader. Moving on to supported interactions. Supported interactions allowed visually impaired people to seek technology advice and support from 2 sources. The first were family and friends. Family and friends would be called upon for ad hoc help. The close-knit structure of Kibera, both physically and socially, meant family and neighbours were close by and willing to help. They would put numbers in phone contact lists, read and reply to text messages, and check airtime credit. A specific support person who answered more complicated requests and who instilled confidence in technology use was also called upon, but less frequently. The enabling factor for supported interactions, be they through family and friends or a specific support person, was that the supporters were part of the social community of the participant. Dependent interactions were characterized by a person who was not the primary user, usually a shopkeeper, directly using the mobile phone on behalf of the VIP. The defining element of dependent interactions was trust. Although dependent interactions appear similar to supported interactions, they differ in 2 important aspects. First, supported interactions only occurred with individuals who were already within the visually impaired person's social circles, whilst dependent interactions happened specifically with shopkeepers and M-Pesa agents outside of this social circle. Second, participants reported feeling they had little control over the situation during dependent interactions, whereas this did not occur during supported interactions. And finally, we have restricted interactions, and these are the ones which are unavailable to the user. These were mainly caused by one of 4 factors: lack of accessibility features on the handset, the cost of devices or services, low digital literacy, and limited capabilities of the handset. they always result in exclusion of the person alongside frustration and disempowerment. Moving on to our results from the co-design session. In the co-design exercises, participants were asked to describe future scenarios in which technology enabled a visually impaired child who would live their life in Kibera to interact with the world in whichever way they wanted. The results were a series of imaginative stories in which our co-designers envisioned that generations of the future would not be held back by a lack of sight. Instead, the built environment would support the needs of visually impaired people, and technology such as advanced talking white canes and talking traffic lights and signage would enable their characters to progress, be independent, and give back to the community. In people's vision of the future, visually impaired children were not restricted when interacting in society. This unrestricted access was possible due to social acceptance. In these new realities, stigmatization was limited, and visually impaired people were high profile. Therefore, there was no restricted interactions, and instead a new category of unrestricted interactions emerged, which are characterized, as I said, by social acceptance. A second finding was that the supported interactions evolved to be bidirectional in nature. On the one hand, assistive technologies, specifically in education technology, supported the future visually impaired children to excel academically and socially, even to university. And in return, their imagined futures had them be leaders in technology, which helped society. And finally, independent interactions were dominant. They dominated discussions and focused on the role of mobile to enable accessibility of the physical infrastructure of Kibera. This is noteworthy as none of the participants in the first study mentioned using their mobile phone device to aid navigation, despite all complaining about the inaccessibility of the physical infrastructure of Kibera. So finally, we'll look at the future visions and aspirations that emerged from our co-design session. And we feel it's important to highlight the themes that emerged in the imagined futures and possible avenues for future design work within the CHI community. So people's future visions and aspired interactions were for technology for navigation, technology which would promote social acceptance, not healing, technology which would provide access to information for visually impaired people and others, including their families. Two-way support ensuring that visually impaired people were creators of content and experience as much as the beneficiaries of technology and support, and that ultimately people wished that technology would be a key enabler in helping the future children of Kibera achieve their life goals, enabling them to reach prominent roles in the community. So our conclusions. Our study finds that the mobile phone in the context of visually impaired people using it in Kibera acts as both a social enabler and an assistive technology. That with current available technology, mobile phone use can be classified as direct, supported, dependent, or restricted. And that accessibility barriers always result in exclusion of visually impaired individuals. Finally, participants' aspirations are for a more balanced interaction experience, where support is both received and given. Before I finish, when we were out in Kibera, we were asked a question by one of the participants, which was, what makes you different from all the others? The others he was referring to were the myriad of researchers who crisscross the lives of people living in Kibera. They come, they ask questions, they write papers, they leave. And nothing in this man's life seems to change as a result. So it's a question we keep asking ourselves. It acts as a reminder that research conducted with people who live in informality can so very easily be extractive. It can do the opposite of its aim very quickly and become disempowering rather than giving positive change to the participants and their communities. And so our handover research approach is aiming to create a sustainable community through collaborations with local university, establishing multiple channels of learning, so we learn as much as we may teach. Contract with local disabled people's organisations for research activities so that they are paid for their involvement and can grow their community. Providing research training where needed and receiving research training where needed. Making sure that all of our research is provided back to participants in an accessible format and is built on by them. We hope that by building a programme of research rather than single projects, we can create lasting change. And so that is all from us. Thank you very much for listening and for UK Aid for funding this project. If you'd like to continue following the programme at at2030.org, please do. We'd love to hear from you. Thank you.